Hey everyone, Morgan here. So we are back to focus on weak acids again. So let's imagine that we have any generic acid, we'll call it HA. It reacts with water, dissociates, forming H3O plus and A minus. Ka can be written. It's going to be the concentration of H3O plus times A minus divided by HA. We ignore the water because it's a pure liquid. Or for a base, A minus, react with water, we end up with HA and OH minus. Kb is equal to the concentration of HA times OH minus divided by A minus. Now we're going to do something funny. We're going to multiply these together. Ka times Kb equals the concentration of H3O plus times the concentration of A minus divided by HA. You see that right here. Times the concentration of HA multiplied by the hydroxide ion divided by the A minus. And when I look at this, what happens is A minus cancels, HA cancels, and I get H3O plus times OH minus, which means Ka times Kb is equal to Kw. That's a good relationship to know. Okay, so now, to draw the distinction between a strong acid where Ka is large and a weak acid where Ka is small, let's think about HCl. HCl is a strong acid. So whatever the HCl concentration is, it becomes the H plus concentration. So if I have 0.10 molar HCl, I have 0.10 molar H plus, fully dissociated. pH equals the negative log of the H plus, which equals the negative log of 0.10, which equals 1.00. There we go. Pretty straightforward. Now what about this weak acid? Since it only partially dissociates, it's got a value Ka there, I have to do an icebox. HC2H3O2 plus H2O gives you H3O plus and acetate ion. Icebox. I'm starting off with 0.10 molar. Can ignore the water. None of this to begin with. Minus X plus X plus X. 0.10 minus X, X and X. So the Ka in this case is the concentration of hydronium times acetate divided by acetic acid. Values given, 1.75 times 10 to the negative fifth. So X squared over 0.10 minus X equals 1.75 times 10 to the negative fifth. So I'm going to assume X is small because of the small value of Ka. I can do my approximation. X squared over 0.10 equals 1.75 times 10 to the negative fifth. X squared equals 1.75 times 10 to the negative fifth multiplied by 0.10. Or when I solve that, my calculator says 0.0013. So we'll let X equal the H plus, which equals 0.0013 molar. So the pH is equal to the negative log of 0.0013, which comes out to be about 2.89. So what happens here is that pH problems suddenly meet up with icebox problems. We'll practice this a lot. Thanks for tuning in. This is Morgan signing off.